Hi everybody, my name is Valery Proskurin and this is my second video about my pet project, esp32 based wireless oscilloscope with web interface. So um, here you can see the signal that I get from my esp32 oscilloscope with real ADC front end. So I spent some time to collect to make new setup based on Venus Lolin 32 board connected to handmade analog to digital converter based on TI chip ADC140. This is a 10-bit 40 megasamples per second analog to digital converter, and it's probably the cheapest converter that I managed to find with such characteristics. This chip also has a very simple connection, typical connection schematic. That's why I selected it for my prototype. So as you can see, the prototype is not really high quality, but it was needed for me to prove the general idea, the possibility to sample so high speed data with esp32 and real ADC chip. So in my setup I use one channel of my oscilloscope to show you the actual input for esp32 oscilloscope, and signal generator output actually to provide some signals for the demonstration. So here you can see the actual signal. It's ESP collects 3000 points, so quite a lot with this high frequency, and we have quite good resolution. ADC chip has 2 volts peak to peak maximum volt input range, and we have 10 bits, so 1024 samples per 2 volt input. So not bad, and probably enough for most of usual needs. So we can magnify a part of the graphic. So as you can see, we have 40 samples per period of the input signal. So input signal is 1 megahertz, and here is actual input signal. So it's 1 megahertz frequency with 1 volt amplitude and positive offset of 1 volt. So actually that's the signal measured with my picoscope, and it's triangle. It's triangle shape. So let me show you how it works with other signals. So here is a sine wave, or square wave. So I hope with normally built PCB with all needed filters and so on, the quality of the signal will be much better. Also, for sure, it signal quality will be much better if you reduce sampling rate. But yeah, at least we know that we are able to sample at 40 megasamples per second, which is really cool as for me. So I hope that you find the project interesting. I will continue to work on it, and my plan is to build extension shield for the VMOS board with ADC chip and all other components that are needed to build another front end for the project. So in my idea, the device will consist of 3 parts. So VMOS LORIN32 itself, plus extension shield with analog front end, which I'm going to design, and the third part will be a small lithium battery, and altogether it will create a very small, very portable, and hopefully convenient and useful wireless oscilloscope with WAMP interface. So you don't need any drivers, any wires, anything. So just connect it to your Wi-Fi network and use when needed. Hopefully it will be a successful project. So yeah, thank you for your attention, and bye.